Standard 4.3. Determine if law of sines is an appropriate formula to solve a triangle and use it to find missing sides and angles in a triangle, including the ambiguous case. Alright, so let's start with example 1. Each example is different, so I encourage you to watch the entire video here. So example 1, we want to find sides using law of sines. If we take a look at our triangle here, our triangle has two angles, angle B and angle C. And angle B and C, oh, I don't know why everything just jumped over there like that. Angle B and angle C, let's put them there, are 85 degrees and 38 degrees respectively. Side C is equal to 12. We want to find side A and side B. So using law of sines to find sides is pretty straightforward. First of all, notice that we can find angle A because we have 2 out of the 3 angles in our triangle. So if we add 85 and 38 and subtract from 180, we get 57 degrees for angle A. Now, when you're determining whether or not you can use law of sines, you want to see if you have a match. You want to see if you have an angle and the side across from it. So notice we have angle C and side C. We have that match, so law of sines would be appropriate. Alright, so we're going to set up law of sines here. We're going to use the C bit because we have both pieces of information for C, the angle and the side. So sine of 38 over 12 equals sine of, in this case, let's find side A. So we'll use angle A over side A. Keep in mind the law of sines looks like the following. Sine of A over A equals sine of B over B equals sine of angle C over C. You're only using 2 out of these 3 pieces. So in this particular problem, we use the C piece because we had all of the C information, and we use the A piece because we're trying to find side A. Now, since we have a proportion here, 2 fractions equal to each other, we're going to cross multiply. So we can multiply 12 times sine of 57 and set that equal to our product A times sine of 38. And to solve for A, we can divide both sides by sine of 38. So 12 sine of 57 divided by sine of 38, and that would give us A. Your calculator should be in degree mode because your angles are measured in degrees, and A is approximately 16.3. Now you could use a similar method to find B. So this time let's use the A piece again the C piece again because we have both the angle C and the side C. And now let's use the B piece because that's what we're trying to find. Sine of 85 over side B. Again, cross multiply, so 12 sine 85 equals B sine 38. And then divide both sides by sine of 38. So 12 sine 85 over sine of 38 equals B. Put that on your calculator and get 19.4 for B. So that's law of sines to find a side. Pretty straightforward. Now let's use law of sines to find an angle. Notice this problem is different because we're only given one angle, unlike the 2 that we were given in the previous problem. So we're given angle A is 35 degrees, side A is 6, and side B is 8. Side C is unknown, as well as angle B and angle C. And again, to use law of sines, we're looking for a match. So notice we have both angle A. I'm not sure why my stuff is jumping around like that, but notice we have both angle A and side A. Here's angle A, and we have side A. So we have our match there. Okay. So let's set up law of sines. We're going to do sine of angle A over side A. And since we have side B, let's find angle B. So it's sine of angle B over side B, which is 8. So far this looks like our previous example. Alright, we're going to cross multiply just like we did before. So 8 sine of 35 equals 6 sine of B. And to get sine of B alone, divide by 6. So 8 sine of 35 over 6 equals sine of B. Now if we put in 8 sine of 35 divided by 6 on our calculators, we get approximately 0.76 ... for sine of B. And to find B, we're going to have to use inverse sine on our calculator. Inverse sine of that number. Now since that number is positive and sine is positive in 2 quadrants, there are potentially 2 different angle measures for B. So if we do inverse sine, we get about 49.9 degrees. And that's a reference angle. So there are 2 measures for angle B. We'll call them B1, which is a quadrant 1 angle, 49.9 degrees, or B2, which is the quadrant 2 angle, which is 180 minus 49.9 degrees, or 130.1 degrees. So it seems like we have 2 possible triangles here. Notice that angle A is the same for both triangles. That's a fixed value. So angle A is 35 degrees. Okay? And now that we have 2 angles, we can find the third one by adding and subtracting from 180. So 49.9 plus 35, subtract that from 180, and angle C1 is 95.1 degrees. Angle C2 we can get by adding 130.1 and 35 and subtracting from 180, and we get 14.9 degrees. And so there are 2 values for angle B, 2 values for angle C, which means that we have 2 different potential side C's as well. So side C could have 2 values. What's happening in our triangle is you can imagine this side BC swinging out this way, being 6 units long, and we could potentially have this red triangle. Nope, that doesn't make sense. We can potentially have 2 triangles. I don't think I'm drawing it right, so I apologize for my lack of preparation, but there are 2 different triangles that we can draw that have these particular measures. Alright, you're going to find side C1 by using the law of sines like we did above in the previous example, and you can find side C2 using law of sines the same way. Alright, let's look at our next example here. Okay. Again, you only have 1 angle, and so we're going to use law of sines to find our angle. We have our match with the A's, right? We have both angle A and side A, so law of sines would be appropriate. We're going to set it up similarly to how we did the previous problem. Sine of angle A over A equals sine of angle B over B. We're going to cross multiply. 5 times sine of 45 equals 3 sine B. We're going to divide both sides by 3. So 5 sine of 45 over 3 equals sine of B. So now if we type in 5 sine of 45 divided by 3 on our calculator, we get 1.17 equals sine of B. Now, if you remember, sine cannot be greater than 1, so there is no possible solution for angle B. If you try to use inverse sine on this value, your calculator will give an error message. So there's no solution here because no such triangle exists with these measurements. All right, let's look at our fourth example. Again, every example is different, so I encourage you to listen through all of them. Again, we're finding angles. So we have angle A is 50 degrees. That's the only angle that we're given. Side A is 8. Angle B is unknown. Side B is 7. Angle C and side C are both unknown. Since we have both angle A and side A, we're going to use those values to set up our proportion. Sine of angle A over side A equals sine of angle B over side B. Cross multiply, 7 times sine of 50 equals 8 times sine of B, and divide by 8 to get sine of B. If you put this value on your calculator, 7 sine 50 divided by 8, we get 0.67 for sine of B. And if we do inverse sine of this value, like we had 2 examples ago, you could end up with angle measures in both quadrants 1 and quadrants 2. So we have about 42.1 degrees. So one possible value for angle B is the quadrant 1 angle, 41.2 degrees. The other possible value for angle B is 180 minus 42.1, or 137.9 degrees. Okay. Notice that angle A is fixed, that's given, so angle A is 50 degrees. And now we can use these two angles to find the third. So if B was 42.1 degrees, we can add that to 50 and subtract from 180 and get 87.9 degrees for angle C. However, if you notice with the other case, if we add angle B2 with angle A, that's greater than 180 degrees. So this triangle doesn't exist because we're exceeding the total number of degrees we can have in a triangle. So we only have the value of 42.1 as a possible value for B, and 87.9 as a possible value for angle C. Now we can find side C by using law of sines. So I'll take the work over here, but you can do sine of 50 over 8 equals sine of angle C, which is 87.9 over side C. Cross multiply and solve like we were doing in the previous example. So 8 times sine of 87.9. You can divide that by sine of 50, and B is, or C rather, is approximately 10.4. So these are our measures. So if you're trying to find an angle with law of sines, be careful, because as in example 2, we could have 2 solutions. As in example 3, we can have no solutions. Or as in example 4, we can have 1 solution. And it's for you to determine which case we have here. Just think about whether or not you have room for a third angle. In example 2, given the 2 possible values for B and the fixed value for A, you had room for a third angle C in both cases. In example 4, given the 2 values for angle B and the fixed value for angle A, you didn't have room for a third angle in our second situation, and so we were only left with 1 triangle. This is standard 4.3 using law of sines.